Okay, it is Friday. So we're going to look at the last 5 problems of Module 10 today. So we are focusing on z-scores and normal distributions today. On this one, it's talking about a raw score on a behavior test. It gives 2 different scenarios. It says that 3rd graders have a mean of 75 and a standard deviation of 10. 6th graders score on average an 82 with a standard deviation of 11. It gives the scenarios for David and Nancy. David scored 78 on this exam and Nancy scored 81. So relative to their ages, because they're in different grades, David's a 3rd grader, Nancy's a 6th grader. So relative to their age, how did they do? Which one did better? Well, David scored a 78. His mean was 75, so you do minus the mean over the standard deviation of 10, and his z-score was 0.3. Nancy's z-score, you take her score, so 81, minus the mean of 82. She actually scored below average, so already I know that she's not going to do as well. And then I divide by that standard deviation of 11 to get negative 0.09. What that would look like is that David did slightly better than average and she did slightly worse than average. So who did better? Well, David. He had the higher z-score. 0.3 is higher than negative 0.09. So David definitely did better on this exam. Okay, the next one is very similar. So you have Veronica, and she took 2 tests. She took this SAT and then the LSAT. Her score on the SAT was an 875, and it had a mean of 998 and a standard deviation of 209. On the LSAT, she scored a 145, but the mean was 150 and standard deviation 9. So I have to do that same thing that I just did. I'm going to have to take the z-score of each one of them to figure out which one she did better on. On the SAT, the z-score would be her score, 875, minus the mean over the standard deviation. She got a negative 0.61. On the LSAT, she scored a 145. I subtract the mean and divide by the standard deviation, and I get negative 0.56. When you're talking about a negative z-score here, so I put them on a normal distribution so I could see it. On the LSAT, she scored a negative 0.56, and then on the SAT, she scored a negative, which is even further away from the mean. You don't want to be negative at all, but on this one, she did do better. You want to be closer to the mean here. She did do better on the LSAT, the LSAT. Higher z-score. Number 18. So number 18 has you do a z-score, but then take it a step further and use that table in order to work backwards. I'll actually get into the table so that you guys can see that in what I've done. But here it says for A, let's say that you know an 8th grader who scored a 135, where the mean is 150 and the standard deviation is 10. So I calculated the z-score first, and they were below the mean by negative 1.5 z-score. So the way I'm getting this 7% is then I go to the table. Let me pull open the table for you really quick. I have put it down here for you to look at. So the Z table. Is it going to take me to the website? Oh no. There we go. Okay, so on the Z table, I look up negative 1.5. Negative 1.5, and that is the value right there. If you remember, negative 1.50, because there's nothing after that, is 0.0668, which I made 7%. Okay, you'll see I put in the table it's that, but it's really 7%. That's the area to the left. That's the area to the left. But luckily, that's what they were asking for here. It said, what proportion scored lower or below that student? So that 7% is my answer. Moving on to number 19. Number 19 actually appeared on a quiz last quarter. I grabbed that one. I love this one. It says, which one of the following has a mean of 60 and a standard deviation of, whoops, I'm sorry, I did not do part B. I did not do part B. So I'm going to do part B really quick. On this one, it says, let's say you know another 8th grader who scores 168. But we want to know how many people scored above them. We're going to have to do something in the end for that above, but I have shaded it. So in this one, I take that 168 minus the mean over the standard deviation to get that 1.8. So what I'm going to do is I'm going to look up 1.8 in my table. So I go to my Z table, the positive one, and I go, okay, 1.80 gives me about 96%. About 96%. But that's the area to the left. Remember, the area in these tables is always to the left, to the left. In fact, you can see it, it's shaded to the left. I don't want the area to the left. I want the area to the right. Since the whole area is 1, I can take 1 and minus the 0.96, and that will leave me with the area to the right, which is 4%. Okay, now on to number 19. So on number 19, it asks, which one of these has a mean of 60 and a standard deviation of 4? Well, 60, 60, 60. These three are possibilities. This has a mean of 72 and that one has a mean of 64. So those ones are out, but these three are possibilities. Well, the next thing that I do is I recognize that all the way out on these tails right here, that's 3 standard deviations away. That's 3 standard deviations away. So I have to think about 60, but then I add not just 4, I add 4 plus 4 plus 4. So I really add 12 because it's 3 standard deviations away. I add 12 and I get 72 here. I would double check myself. Is 60 minus 12 48? Yes, it is. A is our answer there. A is our answer. Then we have this last one. So on this last one, you have that same problem again where you have that 150 for the mean, standard deviation of 10, but now we're trying to figure out what's the probability of people scoring between 2 different values. So what I did for that is I calculated the z-score first for the first one, okay? For 132, you take the z-score, you get negative 1.8. I found the z-score for 165, so minus the mean over the standard deviation, you get 1.5. I went to the table to find the values. So this gave me 4% to the left. This one gave me 93% to the left. In order to get the area in between, I take that 93%, but I have to take out that 4% that I found. So I take 93% minus 4%. I always do that for those middle values, like when you're doing in between. And we get 89% of 8th graders would score between 132 and 165. And that is all for this week.